Yes, it's good.
So yeah, I think the weather next notebook should be visible.
Yes, yes.
Uh, so so yeah, good afternoon, everyone. So yeah, I will be presenting a POC which I did for uh, two different data sets, like two different weather data set which are available to public domain for the analysis and for the, you can say, model training or some uh, like data science data science work. Okay, so I used two data set. First one is provided by Google, which is weather next 2, and second one is uh, or NOA GFS forecast dataset. So yeah, the our today agenda will be covering how each system stores and structures its weather data, understanding the web and ZAR data format, which is available to NOA, the query performance and the accessibility patterns. Also, how we can extract the regional data from this, like terabytes of data. And yeah, I'm doing it specifically for India, so I'll like share that method also. And yeah, so like let's get started with the weather next. So the weather next data set is available through BigQuery if you want all the table, and it is also available in like raster dataset through Google Earth Engine. Okay, so I was using the BigQuery method to access the dataset. So the BigQuery had a table for the for weather dataset, and here you can see the dataset schema which is there on the BigQuery. So first we have it is similar to NoSQL dataset. So we have the init time, geography, polygon, and forecast. So the init time is like the runtime of the model, like when the model was run, and in a day the model runs 4 times. So technically it generates data 4 times a day. So yeah, that is the init time. Next is geography. Geography is like the what Google did was divide the whole world into array of points, and the lat long of that point is there in this geography. And also what they did was cover the whole world into a set of squares, and that geometry of those squares are available in this geography polygon. And obviously the forecast, as the name explains it, the forecast has all the data related to the your weather. So inside forecast, we have these time, hours, and ensemble. So as the weather next is like purely ML based model, so it generates like data for a single point 64 times. So yeah, so what by 64, what I mean is like, let's say temperature. So for temperature, it generates 64 like 64 times temperature. So 64 time temperature means it does like small changes in its model and generates the same data point again and again 64 times. So yeah, and symbol is that the same model is run with like very small changes and generates the same data point 64 times. Okay, so yeah, this was a brief about how the weather next data is stored. Also, the weather next uses Google BigQuery as its primary data warehouse. So as I told, it has 64 ensemble members per forecast, and data is organized by grid polygons. Hmm. So yeah, using BigQuery, we just need to provide it any set of any polygon for like any area for which we want to get the like we want to get the weather data points, and it will like return it in the form of some table, obviously because we are querying it using SQL. So yeah, so here what we did was provide a polygon of New York, and also the timestamp for which we want to get that data, like the init time. Okay. And yeah, we got the 2 meter temperature, which is in Kelvin, and the geography polygon. And next we did was plot the data over a time period, so we can do these statistical work with this data also. And yeah, we also have several other components as well. So as you can see, we have the wind comp. We are using the wind component to make average 2 meter temperature, sea level, and total precipitation for a 6 hour. So yeah, this is the world average, and you can see how many rows entries are there. So these many, like you can say, these many squares build up the whole world map, like cover the whole world map. And yeah, I did this for India also. Mm, So yeah, so here in this we can see I used the bounding box for India, and we can see how many squares cover the India. So it is around 14,838 squares, which covers the whole India. So each square is, I think, around the area of that square is 25 kilometer square. 20, no, it's not actually 25, it's 16. So the square is of 4 by 4 kilometer. So that's a 16-kilometer square area. Uh, so yeah, we also did some, as you know, we have like described in previous community calls also. We do everything on MWS. Like the MWS is our basic unit of data. So we also did the weather query for the MWS also. So we provided the whole geometry of the MWS to BigQuery, and yeah, we got the temperature and temperature. So this temperature is for 15 days. It is an average of whole 64 ensemble members. Just a sec. 64 ensemble members, and we were querying for 15 days time period. So yeah. Also, we did some GE visualizations also, like taking the raster from GE and uh, putting it up on the map. So yeah, actually it's okay. So I need to, I think, run this. Mm, I'll run it and show it at the last. So because I need to switch accounts for this. So yeah. So we also did what we did was provide a tehsil to it from our like publicly available data set. So we chose this place in Andhra Pradesh. We used that tehsil, and then we clipped the weather raster which was available on G for that tehsil. So the temperature we can also, like on G, we can calculate the pixel value. So using that, we calculated the mean temperature of that whole tehsil, and we also did some like performance summary also, or that how much time it was taking to get the data from G, do all the clipping and return it, like return the data value. So it was taking us around 5 seconds, and yeah, it is not very good for making an API from it or like serving it to other people. So yeah, BigQuery is a way to go for weather next, because the weather next data is available in a table, and the weather next data is available in rasters. And there was a two way of doing this. The first way was getting clipping the whole data set for the India's bounding box and keeping it and updating it regularly. And for doing that, we had to invoke some BigQuery queries, which would be doing this regularly. So running those queries is like a bit complex for this. So from this, we concluded that going going with the weather next route was a bit complicated than it should be. And as the weather next, obviously in the docs it is written that weather next data is for data analysis only. And yeah, Google has made the data available through that me through that like through that way only. Okay, it can be only used for this, not for like building an API or making an application from it. So then we moved to the dataset which is provided by NOAA. So and NOAA uses completely different approach, and it is very interesting. Like the what they do is they also have this physics. They have this physics based model as compared to weather next, which is purely ML based. So it has been recognized by meteorological departments, and it is widely used also. So what they did was they provide the data, weather data in grid format, which is stored in AWS S3 bucket. And yeah, you can say the grid is the meteorological standard format also. Hmm. And so here the NOAA dataset is publicly available, and you can and also the grid is industry standard because it is extremely compressed and self-describing. But as we are putting it on cloud, so we are converting it to ZAR, because ZAR is optimized for partial reads, parallel access, and it is like similar to cloud optimized GeoTIFF. So this data is also cloud optimized format. So I will dive a little bit deeper into this. So yeah, you can see like we needed these libraries for accessing the NOA dataset, and we can. Hmm. So it is available from the S3 in this format, NOA GFS. So GFS means like Global Forecast System, and NOA is the like organization which is providing it. And this is like the date for which starting which we will be pulling starting which we'll be pulling the data. So I like for this in this notebook I used the data starting from 3rd February, and this 06 is the run. So basically these models are run for 00, 06, 12, and 18. So this also is like being like runs 4 times a day. So So the data is updated 4 times a day. Data is generated 4 times a day. And yeah, can run it. Okay. So yeah, this is like the this listing a sample GFS run we use to check if we are able to access the like GFS data. So we what we are doing here is we are building this path. So as I explained, this whole path how it is built, like that this part is built using year, month, day, run, and the forecast hour for which we are trying to pull the data. So this is how the data is organized. As the NOA organizes data hierarchically by date, model run, and forecast hour. So we are like working here for with a 15-day forecast at three hours interval. So the data which it produces is at 3 hours interval. Like like if we go for 15 days, so that would be like at 3 hours interval would be around 120 files, which we are uh, like you like we are operating on 120 files for 15 days at 3 hours interval. Next, we what we did was download a grep file locally. So as like we tried to read the like stream the bytes which we need using CF but Collab doesn't allows that. So yeah, we downloaded a single file locally and stored it. And then using the X-array, we started to transform the grid into ZAR. So let's stop here for a minute and understand what is grid. So like I already said, grid stand for gridded binary. So it is like meteorological community standard format for providing weather data. And as it is in binary format, so it is optimized for that. It is highly compressed, and highly compressed, I mean, uh, like it if we uncompress it, it would go for several GBs, but a single file which is available in GRIP format is only ranges from 300 to 500 MBs. So comparing that for whole world weather data is like really small. And also a GFS file might have 100 plus variables like temperature at different levels, wind components, precipitation, and like having that in like 400 MB space, like it tells ki it is extremely space efficient. And it is also the resolution for that data set is 25 kilometers. So at that resolution, covering the whole world in just 500 MB instead of several GB uncompressed is just extremely space efficient. Also, but this also like limits it because grep requires some specialized libraries to read like CF grep, which I showed, and you can't just open it in pandas. And why NOA uses it? Because of the first point, which is it is very efficient. Second, it is also backward compatible with like decades of tools. So that backwards compatibility also plays a part because they store the like historical data also. They make available the historical data for analysis. So having a file format which is backwards compatible is very important. So now talking about ZAR format, ZAR is like recent, you can say a modern cloud native format for storing chunked and compressed and n dimensional arrays. Like it is n dimensional arrays basically. And by chunked, I mean the data is splitted into regular chunks and it is cloud optimized, so it can be stored really efficiently on S3s or GCS. And it can also be used in parallel input output, so that chunks can be read simultaneously. So like ZAR, what it does is organizes data into regular chunks, like you can say like tiles on a map. So when you query a region, you only download the relevant chunk, not the entire data set. So this is very crucial for like cloud storage because where you pay per request and transfer. So you only transfer the bytes which you need, not the whole file. So it is very read efficient also. And each chunk is efficiently compressed, so parallel reads are also fast. So what we did here was we opened the data set using the same grep engine and merged the points which we like data points which we need, which was the temperature, the U and V wind components, and the precipitation. So we merged it into a single data set and then we sliced it to India level. And yeah, so you can see like how the data set looks in ZAR. Okay, it's not even showing the dimensions. So we also did some conversion of units as the weather data sets have temperature in Kelvin instead of Celsius. So yeah, these are some like conversions. And then we have the final data set, which we have the wind speed, rain, and temperature. So we also chunked it before uploading it to S3 because yeah, the ZAR performance depends heavily on chunking, and we chunked it by latitude and longitude. Then we uploaded it to S3, and yeah, let me start to run it. So yeah, after uploading it to S3, we can now open the ZAR locally, and yeah, then we can query it at any lat long. So that query is like just in milliseconds. You can query at any lat long for whole India for like these weather data points. Okay. So what I also did was wrote this script for pulling for whole 15 days. So yeah, so the 15 days, as I told earlier, the forecast hour is like forecast data is available at 3 hours, 3 hours like 3 hours gap. So that is what is being shown here. Like you can see 0003, 06, 09, 12, and so on till 360. So yeah, the stuff is similar to what we did above. And there was two way. The first what I did was download all the grip file locally and do the conversions, clipping, and then upload the India's ZAR, made the India ZAR and uploaded it back to S3. So this was a long process which I did. Like the downloading takes a lot of time from like downloading a 500 of like 400 MBs file or like 120 files, which each file is around 400 MB. So we are downloading around 35 GBs and doing that every day for several runs is like not very efficient. So yeah, so what we did was there is an organization called Dynamical. So what they do is they also use this NOA dataset. So what they do is like take the dataset and convert it to ZAR. So the part where we are downloading and converting it to ZAR was already done by Dynamical. So what I did was stream the dynamical data and like slice it to India level using pandas. So for grip you can't use pandas, but for your ZAR you can use pandas. Okay. So yeah, so I streamed only the byte, like only the part which I needed from the ZAR, and it was really very efficient compared to downloading all the files and converting it to ZAR and putting it to S3, which took me around, I think, 2 hours, or like it executed in 2 hours. This whole script was executed in less than 5 minutes. So yeah, this shows how how cloud friendly the ZAR format is, how easily you can clip the data from it, and yeah, how easily you can like query the data, like clip the data, query the data. It is in matter of seconds. So it is, yeah, it is like really good. So yeah, any questions, any doubt, or anything you want to add to this? Hello, am I audible?
Yeah, Kshitiz.
Okay.
Uh,
So yeah, any doubt, any queries, or anything you want to ask?
Hi,
So
Kshitij. I have a couple of questions. Can I ask them now?
mhm.
Sorry, can you hear me, Kshitij?
Yes, Trishul, you
Okay.
can
First of all,
go
thank you
ahead.
so much. I think this analysis is very cool. Anytime I see ZAR, I get quite excited because of how novel it is, and more importantly, how much it saves our cloud compute costs.
Mhm.
Thank you for that. I just have two questions, Kshitij, you can help me understand. First is that uh, Now, I haven't worked too much with weather, so please take this with a pinch of
Yeah.
salt. Whenever weather enters our workflows, our go-to source, be it as an API or from AWS's Open Data Registry, is Open Meteor. And from what I understand, the NOAA's datasets and the European datasets, they're both available on Open Meteor in a manner in which it's
Yes.
easily queryable. And I think they do have ZAR support as well. So I think my first question is, um, what did you see as these two weather datasets adding on top of Open Meteor? Why you chose them per se? And second is on the BigQuery part, right? In again my limited experience, it's been quite expensive to use BigQuery, and we've
Yes.
often relied on it when we're joining data from multiple tables, right?
Mhm. Yes.
Because the table scan it happens much faster there. Again, our usual workaround when we're working with just one or two tables is to use a ZAR on our cloud storage buckets on any platform, and then, like
Okay.
you only mentioned, use Xarray to extract or chunk what we need. So my question is, did you find what was your experience in terms of costing? Particularly now that Earth Engine's free tier has now been removed and we're all paying for it.
Yeah.
What was your experience with BigQuery? Yeah, just
Okay.
those two.
So yeah. So initially, when we were like doing the POC for weather next two dataset, at that time the GE costing was like the previous one where it was in free tier. Okay. So at first we were not like quite like comfortable with you using G to serve our like serve the weather data to us, because sometimes like G just doesn't respond or like responds very late. And the thing which we are building right now, like you can say, for a short term we are building an API which should respond in just milliseconds. Okay. So that API should give us a lat long, and we should return the weather data related to that. So GE can do that, but it would take some couple of seconds to do it. Like querying, like we can build an infra and like we can write the scripts which can do this, but doing it on GE is uh not good thing. Like an API which responds you in couple of seconds is not good design. Okay.
Yeah,
So first what we did was we tried to like use weather next in like in the form like we will take the downloads of the data from it, and then we will serve that data from our end.
great.
So when we used BigQuery to like get extract the whole data, so BigQuery obviously is a SQL, like using SQL. So we were extracting tables from it and storing those tables like on our servers and updating it constantly. Like if we say like the model updates data 4 times a day. So if we go for it, if we go for 2 times a day, we would be dealing with quite large data set. Like for India, we I think calculated it was around 15 to 20 GBs of like say we want to serve 15 days of forecast. So like getting weather next data to do it and downloading it on our end, putting it on our end would require like around 15 to 20 gigs of storage space, and querying that data uh, like would be very hectic. It would be fast, but it would be very hectic. And BigQuery is not made for real-time queries actually. BigQuery is there for like data science, but not for real time, because it also takes it also like you said, okay, it does joins and all the like table operations. So it is, yeah, it is very efficient, but building an API using that is like not not a good architecture. So then we moved on to like we started looking for alternatives, because Weather Next was like purely for research purpose only, and they were not providing any way through using which we can build something which would like serve the like data to them in matter of like milliseconds. So we moved to NOA. So what NOA was like, it is publicly available, you said, as yeah, and it is also available on AWS public registry. So from there only we pulled all the grib files first, like, and like I showed, we transformed it into zars and put it the zar into S3 bucket, and now we are querying the S3 bucket, which is like returning the data in like milliseconds, which was quite good. So, and like when we clipped the data for, I think, in when we clipped the data for India level and for 15 days, it took only 66 MBs of space compared to 15, 20 GBs, which would be dealing with weather next if we like have gone through that route of taking like using the BigQuery, clipping the data to India level and putting it on our servers. So when I read about ZAR and how it is handling this, like how it is doing this in, like how it is storing the whole India's data on in just 66 MBs of space is like really amazing. If you, if I say what I think about it. And yeah, you suggested Open Meteor. So yeah, I haven't looked at it yet. I didn't know about Open Meteor. So yeah, I'll definitely take a look into it. But the Open Meteor dataset, I think, is available for non-commercial use only. And if you want to use commercially, you need to pay. So that was
Okay,
also.
that's news to me. Right, we've built out a bunch of pilots using it because again, from their open S3 bucket, it's not even so. Unlike the other, say, if when you pull Landsat data and stuff from S3 buckets, now it's a request as pay architecture. We're actually paying for every call that we make to their buckets. This doesn't even seem to have that. So, but no, but thank you for that clarification. It can help me
Yeah.
not make that mistake moving
And
forward. But
yeah, also I read about terms and usage of NOA and WeatherNext. So WeatherNext like were vague about it. Ki we can use this data commercially, like we can use this data, do some transformation and serve it to other people. So they were a bit vague on that. So we also refrained from using that for that part also. As we will be in future, we are thinking of providing this data set with our core stack core stack infrastructure. So it would be like plug and play kind of thing. You can just use the Docker installation, hit some APIs from like on the Django backend, and you will get the data up and run. Like you will get the data in your S3 bucket, and you can like query it directly. So we are also thinking about that also. So yeah, these are the like check boxes which NOA ticked for us. So that's why we use the NOA dataset. Yeah. And yeah,
okay.
if you like, if you know other dataset also, we are like open to say open to your suggestions. We can use those dataset to like reinforce our current data. So our data becomes more accurate.
I have no experience with this, but IMD's data is where my head first goes. But working with
Okay.
in government APIs has not gone well so far for me. It can
Mm-hmm.
be zero platforms or IMD platforms, but
Mm-hmm.
yeah.
Yeah. So yeah, thanks for sharing Open Meteor. I'll surely have a look into it. And yeah, I'll and yeah, guys do any other guys have any question or like, or we can move forward. because I also had one more interesting thing to show you guys. Like,
Yeah, Shitish, maybe we can go ahead.
so yeah, you guys know about the co-stack challenge. So apart from that, we also have our explore like KYL Explorer, who which which is like also whose code is also open source, and we have made some issues for like some new features and some existing enhancements. So you guys can also, like, if you are interested in working on front end, like, I know I think most of the guys like to work in front end. So yeah, there are some good first issues which you can like pick up and start working and start contributing to KYL. And as it as your issues get resolved and PRs get merged, you will be able to see your own code, your own logic, your own like work work live, and which public would be using, which NGOs would be using to get the inference from the data. So yeah, do do you guys do have a look, like what are the issues. And yeah, it does have some interesting issues to solve. And yeah, if you guys are like excited to work in front end, so you can start here. So yeah, I mean, like, I am I'm finished with my agenda, so you can go ahead.
So, Kshitij, what I was thinking is like we are almost at time. So maybe you
Hmm.
can give a short demo of KYL as well,
Okay, okay,
because
okay.
Pawan's work will
So
take some time.
okay, okay. So, like, let me give you a brief. So, we built this KYL dashboard to like use and like give some insight into the data set which we have made available. So you can see, as we have always like pressed on about MWSs. So here also we have the Tehsil Mandalgarh, where we have displayed these blue MWSs and black are panchayat boundaries. So using the data which we provide in our APIs, like related, let's say related to land. So we built out some filters, basically not features, filters. So using these filters, we can identify areas which have these characteristics. Like, let's say we want to see the areas which are broad slopes and hilly and also mostly plain. So yeah, you can see these MWSs are highlighted, which are like showing the areas which are broad slopes and hilly and mostly plains. And let's say we want to identify area where the double cropping over some years is less than 30%. So yeah, we can see these areas are highlighted where the cropping is less than 30%. So like this is like Tehsil level dashboard, which NGOs or the people who are like block coordinators or like NGOs who work on Tehsil level use it to identify areas which need some kind of interventions. Okay,
For
so
planning.
like yeah, yeah, planning, like intervention and planning are interchangeable words, but yeah. So like for planning, let's say NGO wants to do some mango plantations, and the mango plantations can be done only in mostly plains area, and where the like the percentage of water availability in Rabi should be between this. So using these filters, he can easily identify areas which match these characteristics. And also we have a Tehsil report and water bodies using which you can see water bodies. So these water bodies are like these yellow lines are water bodies. So you can also apply filter, and the water body also get filtered on the basis of MWS. So we also provide some reports, like if these MWSs are selectable, if you like go ahead and click on it. So yeah, so you can see we show a micro watershed profile here. So yeah, it will take some time to load. And also if you click on a water body, we also have water body profile, which shows the availability and rainfall of the water and also the cropping pattern near the water body. So these kind of data, which is sure, like which is important for the block person or block coordinator to like for the planning. They can use these report, and this MWS report can also be used in planning. Like in they use this MWS report to submit their demands in like Gram Panchayat or Gram Sabhas. So technically, we can say that they use these reports to support their demand scientifically. Because let's say they want to have a well, and how they can support their demand, ki this demand is valid or not. So they use these scientific datas to support their demand, ki yeah, my demand is valid, I need this to be fulfilled. So these report help in that part. And also if you want to analyze any micro watershed, ki what is happening there, how it is, like let's say we have a section of terrain comparison of block and MWS, ki how much area under the plane is in MWS as compared to block. So these kind of metrics is also there. And we also provide the notes about from where we have took the data. So yeah, we built this dashboard using the dataset which we provide via our API. So yeah, and also we do have some patterns here. So rather than like uh, mixing and matching some filters to do some kind of planning, we can also use some pattern. In patterns, let's say we have in water, we want to see the groundwater stressed areas. So we just use apply pattern, and it has some like it uses some combination of filters and shows us this areas which are groundwater stressed. And yeah, it is in Rajasthan. So might be possible. So yeah, so these kind of dashboard we are building using the dataset which we provide. And yeah, MWS helps us a lot. Like having the data at MWS level gives out the characteristic of that whole area. So that is like helpful in showing like what is happening in that area. So yeah, you guys can also use this dashboard, and if you like think if there is a feature which can be added, if something it can which can be improved, you can open a new issue here and get that issue assigned to yourself, and make a PR and contribute to this dashboard. And yeah, you can like then see this dashboard being used by a lot of people, and they would be using it for planning and other parts. So yeah. Let me provide these links in chat.
And you can explore our website as well. Most of these details are, are mentioned there. These links and our technical manual videos of previous sessions. So those things are there, right? So you can explore that.
Okay. Okay, I just also wanted to add just one point that see the earlier presentation was very good regarding the weather's estimation, but the main thing about this whole platform is I think when we are able to combine data from that to this dashboard or anything like we can build or if we could also integrate things like the like Trishal built last week to this application so that village people can go out to their villages and verify what plantations they did actually, what which kind of provide the ground truth also into it, and there can be many more elements that can be added. You can also show it to other people so that they can or people who you may know live in villages, so that they can also ask for their own requirements, how which element can be added to it, how certain design element can be presented differently so that it's more useful to them. And then we can build a lot of things, integrate a lot of things together so that it keeps becoming more valuable to so many people who depend on agriculture and who so far haven't had so many technological advancement that they could actually utilize properly. Uh, so I hope that you could also um, help these people directly who are the end users, and you can keep connecting and let others join in and invite others also, whoever you may know has some knowledge about these things, or who wants to learn and can contribute. So yeah, just this much. And thanks, Kshitij, for explaining this KYL also with example. It was really helpful.
Yeah, thanks, Amit. Aman, I think Shivam wants to present something. So
Sure, sure. Please go ahead.
yeah.
Correct, I heard.
Hi, Shiv.
Hello, sir, am I audible? Is there some disturbance?
Yeah, but it's very much noisy. So,
Sir,
Shiv,
just a sec. I will just change my location.
sure, sure, but if it is okay, you can present next week, maybe,
Okay.
because
I
most
have,
of the people
I
have
have just, I have made some progress, but I had to show. But it's okay. I will present it next week.
Sure, sure. And you can send your work over email as well, right? And on the
Okay,
Discord group.
okay, I'll share it.